All right, flip geometry, this is it. It's the final section of the textbook. If you can clear this hurdle, you will fly over the bar and land comfortably in summer vacation. Well, you know, there's probably summative evaluations and things. But anyway, you're there. Here we go. One big push, and we'll get this thing done. Chapter 12.6, Law of Cosines and Law of Sines. Let's jump in. So far, we've been doing sine and cosine and tangent with right-angled right triangles. What happens if your triangle is oblique, meaning it's not a right triangle, it's an acute triangle or an obtuse triangle? Can you still do trigonometry with it? Wouldn't it be wonderful if you could just say, can't help you here. Sorry about that. Nothing I can do. Nope, you can still do it. Here's how you do it. Meet the law of cosines. It's been waiting to meet you all year. It's so excited. I bet you are. For any triangle ABC, remember that a squared plus b squared equals c squared for a right triangle. Well, for any triangle, Pythagorean has a cousin called the law of cosines. A squared equals b squared plus c squared minus 2bc cosine A. And you're like, what? I just heard letters. Yeah, look at the pattern here. If I want to know the length, the measure of side A squared is equal to the square of the sums of the other two sides, kind of like the Pythagorean theorem. But then I have to subtract 2 times b times c. These are the other sides of the triangle. B squared, c squared, 2bc, okay, same letters as you have over here, times the cosine of the angle A, the angle opposite this side of the triangle. So if you're looking for A, it's A over here, and everything else is B and C. If you're looking for B, it's B over here, and everything else is A and C. If you're looking for C, it's C over here, and everything else is A and B. Okay, so that's the pattern for the law of cosines, you know, in my class, you will always be able to have that table of theorems. So this is just so you know which one to use. You don't necessarily have to commit it all to memory. All right, let's see how this works. So in triangle ABC, I want to know what is length A. Measure of angle A is 57 degrees, and B equals 6, and C equals 9. B is 6, C is 9, A is I don't know, but it's opposite a 57-degree angle. All right, let's figure out how long this is. So a squared equals b squared plus c squared minus 2bc cosine A. So it's the A side I'm looking for. It's the cosine of the A angle, but then everything else in this equation is b and c. B is 6, c is 9, 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of 57. They didn't show their work. Sorry about that. But if you just look at this, 36 plus 81 minus 12, that's 108 times this, whatever the fraction this is. If you simplify all of that, you get 58.2. So A squared, is about 58.2. So A then is 7.6. So you have to take the square root of that and you wind up with 7.6. All right? If you don't understand that, play it again. We'll do several examples in class. The law of cosines can also be used to find any angle measure if you know all three sides. So if I want to know what is the angle measure of A, I can rearrange the law of cosines to solve for the cosine of A, and then leave everything else piled up on the other side, and I can figure out what the cosine of A is. So cosine of A is b squared plus c squared minus a squared divided by 2bc, excuse me. So again, here's the pattern. Squared of the two sides that aren't the same letter minus the side that is the letter, divided by 2 times the two sides that are not the letter. Okay? So cosine of A is only here, everything else is BC. Cosine of B is only here, being subtracted, the rest is AC, etc. Let's solve triangle ABC. I know one side I know one angle, and I know two sides. So here I have a perfect situation to use the law of cosines. And first I'm going to discover what is the value of c here. So c squared equals a squared plus b squared minus 2ab cosine c. Or again, c, a's and b's. Okay. Plug in what I know. Solve. So c squared is 48.5. C then is about 7. So the length of this side is 7. This is a 5, 6, 7 triangle. And 78 degrees is the angle measure here. Now I know everything except the measure of angle A and the measure of angle B. Well, if I have all three side lengths, I can use the law of cosines to figure out what the measure of angle A and the measure of angle B are. So let's go ahead and do that. Cosine of C equals a squared plus b squared minus c squared divided by 2ab. And I can plug all of that data in, and I figure out that it is in fact the cosine of C is 0.7121. Now all I have to do is take the arc cosine of C, the back through the cosine, right? And figure out what's the angle measure that has the cosine of 0.7121. And I discover that the measure of angle A is 44.6 degrees. So I can plug that in. And now I could do the same thing to find B, or I could just use the Pythagorean theorem. Not Pythagorean, sorry. The sum of the internal angles of a triangle. 180 degrees, this is the sum of the internal angles of a triangle, minus 78 minus 44.6 equals 57.4 degrees is the measure of angle B. All right, we'll do several like that in class. Another friend just joined the party. His name is the law of sines. Now, law of sines you can use when you know an angle and its opposite side, and another angle but not the opposite side, or the opposite side but not the other angle. It's a proportionality, and it's super useful. Super useful. If you know the proportionality, the ratio of a side length to its opposite side, its angle, then you can use that proportionality all the way around the triangle. It's pretty neat. So the sine of A, measure of angle A, divided by the length of the side opposite A, is equal to the sine of B divided by B, or the sine of C divided by C. Now, if these are equalities, these all equal 1. It doesn't matter if you take the reciprocal of this whole thing. Like 3 over 3 is 3 over 3, right? It doesn't matter how you rearrange that. So you can also use the law of sines where the length of side A divided by the sine of angle A equals the length of side B divided by sine of angle B, etc. Okay? Super useful tool. Let's show how you use it. A ranger in a fire tower spots a forest fire 53 degrees south of east. Another ranger in a second tower 12 miles due east of the one that's here sees the same fire 45 degrees south of west. Where is the fire? Find the distance from each tower to the fire to the nearest tenth of a mile. This is actually how fire towers work and how they do in fact find wildfires. So let's explore this. Find the distance of the tower from the tower to the fire. Measure of angle C. I know this angle and this angle. I can just use the sum of the internal angles of a triangle. Find out that that's 82 degrees. I'm going to plug that in. Okay, all right. A over sine of A equals C over sine of C. A over sine of A equals C over sine of C. Sorry, C over sine of C. So I know this side length. I know this angle measure. That's my ratio. That's my proportionality. I'm going to use that to figure out what this one is. So A divided by the sine of A, C divided by the sine of C, A divided by the sine of 53 degrees, 12 divided by the sine of 82 degrees. Simplify. A is about 9.7 miles in this case. I'm going to plug that in to back into the proportionality now to solve for B. Okay, B over the sine of B equals C over the sine of C. Plug in what I know. B is the unknown length, but sine of B is sine of 45 degrees. And I just need to simplify here. And B is 8.6. So this was 9.7 miles. This is 8.6 miles. They can now tell where the fire is. Pretty cool. Remember when we did vectors way back when? Now we're going to use trigonometry to solve vectors, which is actually a really handy way of doing it. So A youth group hikes from their base camp for 3 miles heading southwest, 45 degrees south of west, and then hikes 4 miles heading 60 degrees north of west. Describe their final location in relation to their base camp. So, here I have the triangle of their route, and I'm looking for the resultant vector. They went here, then they went here. What's their position from base camp so we know where they have to go to get home? Okay. So I plug in everything that I know here, and I can find out the measure of angle B. I don't necessarily know that, but this was 45 degrees because they left on a 45 degree heading, so there's 45 degrees left of this angle, and then they left at 60 degrees north, so there's 30 degrees left over here. So measure of angle B is 75 degrees, 30 and 45. This is 45 plus something. I don't know yet. B squared, this side length, the resultant vector, equals the two sides I do know, right? The sum of their squares minus 2 times 4 times 3 minus twice their product, times the cosine of 75 degrees, this 75 degrees that I found here. When I simplify all of that, I get 18.8. So B is 18.8. That's the length. I'm sorry, that's squared. That's squared. Square root that. 4.33. There you go. 4.33. Now I need to know this measure right here. Well, this 45 plus something. I can solve for this whole angle and then subtract out the 45, and that will tell me what this is, right? So let's solve for this whole angle using the law of cosines as well. B squared plus C squared minus A squared divided by 2ABC. Sorry, not 2ABC, 2BC. And I'm going to plug in what I know, and I'm going to find out that cosine of A is 0.4533. Take the arc cosine of that, the opposite, and find out that the measure of angle A is 63 degrees. This whole thing is 63 degrees. And then I can just subtract out the 45 that I know, and I figure out that angle A is 18. So they are 4.3 miles at 18 degrees north of west from their base camp. Now you could have also used the law of sines for that last step, because I had the relationship here of a distance and an angle. Excuse me, here I could have used the same relationship and solved for it there too. Either way, we're done. That's it, folks. We're done. We finished the book. So let's celebrate day after tomorrow. But first, we get to do all of this work. So if you have any questions, put them in the comments field below, and I'll get to them as quick as I can. Otherwise, until then, God bless you. Jesus loves you, and so do I. Good night.